Then beyond that, in the case of this aromatic system on this Mercedes, we want to do some more testing. If you have conditions where there's no DTCs, but maybe the battery's running down, or maybe there are drivability concerns as far as suspension, the ride, maybe the system's lacking, it's moving down, it's dropping. Usually there'll be a code associated with that. If there's a sensor that's unplugged or bad, there should be a DTC, but we don't guarantee that. So one thing we can do, thinking outside the box, is look for the source of leaks. Where is it leaking at? Now, a lot of techs would use some soapy water around the airbags themselves, around the top where the pressurized line goes in the top of the air spring, and that's fine and dandy to do. But one thing you can do is think about, what do I have in my shop already that does leak detection? Most everybody has a leak machine for evap work, and you can use evap smoke detector or smoke leakage detectors on other things such as wind leaks, water leaks on vehicles, exhaust leaks, and so forth. Now, the problem we run into when we're looking for leaks with a evap leak tester is it's only about 1/4 to 1/2 psi of pressure is all they put out. And evap systems, it's very small leaks we're looking for, and they're not a big pressurized system. So just a tiny bit of pressure is better than nothing, because we can hook it up to the battery. We can take our little adapter here, and right here where we can pull out the connection, right here is our compressor. There's our output of our compressor. We can pull that line out with a wrench, and we can adapt in with this little cone, and we can turn on the system, put some shop air back here, and turn it on, control the flow of smoke this way, and also look for the ball. Now, since this system is supposed to be a contained system, it's not like an evap system where we're going to have some leakage, let's say, out the vent and through the canister, or we'll have a certain amount of allowed leakage. This is supposed to be an airtight sealed system, just like a tire. So the ball should never be in the 30 or 40,000, whatever would be acceptable for an evap system. The ball should initially go up as we push a little bit of pressurized air and that smoke into the system, and actuate those solenoids, of course, with your scan tool if you can. And as we are adding and taking out air, so forth, from those systems or from the solenoid block, you're going to want to see where any of that smoke leaks out. And let's say you don't see smoke leaking out, you'd want to also look at where the ball is. Once we've had maybe a minute or so of filling the system up, if even that much, maybe more like a few seconds, we want to see that ball on the bottom. If the ball's not floating, you're not leaking. But if the ball's on bottom, it's a pretty sealed system for low pressure. So here's where I want to think outside the box even more. And if you do diesel work, you may have one of these already. Even if you're using gas, you're doing a gas engine work exclusively, you've got a lot of turbochargers with intercoolers out there. So these higher pressure machines have been taking the market with some pretty good popularity lately. And what they're designed for are things like intercoolers, turbochargers, superchargers, intercoolers, and they can run up to 50, 60 PSI, which was the smoke machine to maybe 1/4 PSI. So the adapters that come with these machines, you don't necessarily have to use them if you just use your MacGyver head. For example, I kind of played around with this earlier, and I was able to push this little cone in there firmly enough, and actually with shop air to the back of my machine, go ahead and I'll break out of this menu and go to leak test. There, smoke and leak. And I'm going to dial the pressure up to about 60 PSI, the maximum this thing can do. And you know that pump can put out more than that. So let's run it on up, 60. We'll hit the check mark, and I'll hold this in nice and tight, and I'll say start. And as you see this little bar graph build up, it's showing you what's going in and what's coming out. So 60 PSI is what's coming in, 54 PSI, up to 60 now. We're holding it. So that's telling you if you're leaking. So not only do you look for smoke, in this case, cut my finger over it, but if I took my aromatic line loose and I pressurize the system from here, now I can see smoke throughout the system, the lines, the actual air springs, I should say, and everything else, but also see what the performance is of its sealing. So once we've introduced a higher pressure into the system and looked for smoke, we don't see the smoke, we can see one more test, and that's called the leak test. So now the leak test is not going to send the smoke out, but it's going to do the same in versus out. What are we holding? What are we able to hold? We're able to hold 60 PSI. All right. Then we press the leak test button, which gives us decay. So we're going to see how long we can hold that 50 or 60 PSI. So we got 8 seconds, 7, 10, 6 seconds, 5 seconds. We're counting down from a few seconds, and we're going to see a performance rating of how well we held that pressure. And we did. We had a half a PSI drop, courtesy of my finger, over a 15-second drop. So you get the idea. If you were hooked into the aromatic system, either at the actual air spring, you could unhook it there, or at some of the solenoid blocks up here, you could check those lines and you can check those springs with higher pressure and smoke and even leak decay, doing much of the same work the computer tries to do, but maybe it didn't this time, didn't set the code, and you needed to go in and do a little bit more invasive work to diagnose it and fix it right. After all, on a Mercedes like this, expensive on these suspension systems, no guessing allowed.